So this first example is about a fan that has 3 different settings. You can turn your fan on low, you can turn your fan on high, or you can leave it off. Okay? My brother, when he was young, slept with a fan on, and now that he's an adult, cannot sleep unless a fan is on. In fact, he has a little travel fan that he takes with him on trips, because he'll be in a hotel room and he won't be able to sleep unless he has, I don't know if it's the noise and a little bit of wind. Whatever. So here, you're like, okay, you've got 3 different fans. You could position them in different places in your room, and depending on what kind of environment you want, you could set them at different things. You could have like the calm night, they're all turned off. Or you could have the stormy night, you put all 3 on high. How many different nights could you go with a different environment? That's what this question is asking. Okay? So if we, what we're going to do with this, we're going to use the shortcut first because it makes it really quick. Okay? We could say that you would have 3 decisions to make. You've set up your 3 fans in your room. You have fan number 1, fan number 2, and fan number 3. And in fan number 1, you have 3 choices. You could have it off, you could have it on low, or you could have it on high. Right? Fan number 2, 3 choices. Fan number 3, 3 choices. Multiply them together. There would be 27 of them in total. You could almost go a whole month with a different night experience with the winds in your room if you just bought 3 fans, each with off and low and high. If that would be like, ooh, what kind of, how am I going to sleep tonight? Okay? Now, if you had to list them all, which would be annoying, but we're going to do it. Okay? It would be nice to have a systematic way of writing them down. So what we can do is we can draw something called a tree diagram. A tree diagram looks like this. For your first decision, fan number 1, we draw 3 branches because, and we call these branches, so that's why it's called tree diagrams. Trees have branches, and this has branches. You could have fan 1 set at off, low, or high. Then, whichever one you choose, fan number 2 could come off, low, or high, off, low, or high, off, low, or high, right? If you chose off first, then you could set your second one at any one of those 3. And then your third one, wow, could be off, low, high, off, low, high, off. High, off, low, high. Oh my goodness. Whew. And in the end, can you see that there's 27 things listed, right? And the first set of branches all together, that would be, ooh, very nice sleep with all of them off, right? You could pick other ones, like this one here would be, oh, well, that might be a little scary. If you want a more humorous night, you could probably choose this setting. They'll all be good. But if we wanted to, we could list them all 27. This would be a systematic way of getting them all down. What's annoying about the tree diagram is it gets very big very quick. What's nice about the fundamental counting principle is that you can count things quickly and easily. So here, you could have 27 different nights in a row with a different wind setting to go to sleep. Very nice. So this idea of drawing, okay, when they write it out mathematically, in the definition on the next page for the fundamental counting principle, this is what we've been doing. Mathematically, it's very confusing to read. If there are n1 different objects in one set and n2 different objects in a second set, then the number of ways of choosing one object from each set is n1, n2. Okay? What did we describe it as? Make a space for each decision. That was the first thing that we did. And then we wrote the number of choices for each decision. Because what they've done in their one is they've only done 2 spaces and choices in each one. You could have more decisions. What we had in our fans, we had 3 decisions that needed to be made. And so on and so forth. And this is called the fundamental counting principle. It is the way that you can count big things quickly. And we are going to be counting some very big things. Oh, I've got an example to do after this last one. All right, passwords. This is one of the huge areas of the fundamental counting principle. You guys use passwords all over the place, right? This wasn't such a big issue 50 years ago before computers. You didn't have a cell phone that you needed a password to get into. But now almost everything digitally needs a password, right? And then they change it and they say you need a capital, right? Do you have any passwords that you had to change because they upped the security, right? They say add a capital. What do? You just change the first one. Everybody does that. Then you get one, add a number. And what does everybody do? They just put a 1 at the end of the password they had. And then you like have to add an exclamation mark at the end of that. Right? Password for me to get into my computer now is 16 letters followed by 2 numbers followed by a special symbol. Oh, I just told you, go ahead, break in. Good luck. There's so many possibilities. We can figure out, this is where the fundamental counting principle comes in, is we can figure out how many passwords are possible, and then what are the chances of someone breaking into your password. Okay, so here is an online banking account. 2 letters followed by 5 digits. This one isn't very strong. So what do we have? We have 7 decisions that you have to make when making this password. You have to decide on 2 letters followed by 5 digits. And it says you can use letters or digits more than once, so that this means that you're allowed to use the same letter twice or the same digit twice. How many passwords are possible? So I wanted to guess yours. What are my chances of guessing it correctly? So, oh, this is a good question. Do we know how many letters are in the alphabet? 26. And see, this is interesting. In certain languages have more or less letters in it than other languages. For example, Spanish has more letters than English because they consider this a different letter than this. And here's a weird one for you. That is a different letter than that, even though it's 2 letters. Some dictionaries in Spanish have the double L as its own letter, even though it's 2 letters. So 26 letters in the English language. Do you know any languages that use very little letters? The Hawaiian language uses very little letters. So when you hear words in Hawaiian, they just keep on going on forever because they have their words are longer because they don't have as many letters to work with. So they end up with longer words. Okay, anyways, we have 26 letters in the English language. So 26, 26, how many digits? 10, 0, and then 1 through 9. So this would be 10, 10, 10, 10, 10. All right, a little bit of mental math to start off with. What is 26 times 26 times 10 times 10 times 10 times 10? All right. I think so. That's a lot of passwords. Your chances of getting it right aren't very good. Okay? But there are programs. You could have a thing that goes through them. Computers could go through 676, no, that's 67,600,000. There are computer programs that could go through that quickly. So what is added security that banks or online things put in? Right? Have you ever been working, like, oh, I can't remember my password. Try once, get it wrong. Try twice, get it wrong. And then they start saying, you have 3 more attempts. Have you ever been on those where they say, this is your last attempt, otherwise your account will be locked for 24 hours? Super frustrating, especially when you accidentally had the right password the first time, but typed it in wrong. And you're like, oh, and that last one, you're like, oh, I need to try it. So then you get locked out. And then I hate the ones that say, okay, you've been locked out. You're going to have to reset your password. So you go to reset your password, and then you type in what you want your password to be, and they say, sorry, you're not allowed to use a password that you've used in the last 6 months. So what do you have to make up a new password, which what? You're going to forget. To list them all? There is a way to list them all. It just takes a very long time. You could make a tree diagram. Do you know what the tree diagram would look like? 26 branches off the first one. A, B, C, D, E, Z. And then off of the A, you have 26 off of that one, right? So, and then off, right? And then off of these ones, 10, and 10, and 10, and 10, and 10, and 10. And then off those all 10. You'd have this huge tree diagram, but then you could list them all. It would just take you a very, very long time. But for us to count how many passwords were possible, we just counted a very big number very quickly using the fundamental counting principle. And right now, this wouldn't be enough for internet security. Usually, what do they say? At least 8 letters? At least 8 things? Numbers or digits? So you're not forced to say no, right? Then you have 36 possibilities in each one if you're allowed numbers and digits wherever. Add capitals. Then your letters change from 26 to 52. So 26 to 52 plus the digits, you're now at 62 for each thing. An 8-letter password, 62. If you just used not even special symbols, 62, 62, 62, that's 62 to the exponent of 8 is a very, very big number. Chances of getting that password are unlikely. However, they've been increasing security on things even more than that, because there are computers that can figure those things out quickly rather than, right? They can just keep, a robot could just keep trying things until they find something that works. So they need other things built into it so that it would take too long for the computer just to guess and check and figure that out. All right, we're going to do another example. Has anyone ever gone to the restaurant called Subway? Yes. So now, you know when you go into Subway, you choose your bread, then you choose what kind of sub you want, then you choose all of your toppings. So what we're going to do is we're going to propose that instead of having those choices, that Subway put out a menu for every single sub that's possible. How big would that menu be? How many decisions? Here we go. So we need to make a space for every decision when you order a sub. Every decision you make is a space. What's the first thing you decide on? Bread. Okay? How many choices are there for bread? I think 8? 10? 10?
There's actually wraps and flatbread and then
I like the new, what's that Mex? What, 8? 8?
9.
And then what do you choose next? You choose your basic, what sub you're going to have, right? Either like the steak and cheese or the veggie or the, right? You choose one of those ones. How many choices do they have on the menu for that? 12? Okay. That's our type. And then cheese. How many cheeses are there? 5 cheeses, plus you could choose no cheese. So we're gonna go with. And then what? Sauce? The sauce isn't until these. Toasted or not toasted? TNT. Two choices, because it's either toasted or not toasted. Oh yeah, the 6-inch or the 12-inch. So we'll just. Okay, yeah, let's do it. 6-inch, 12-inch, 6 or 12. And then what's then we get into the veggies. So each veggie is its own decision, right? So let's just list them off. Lettuce. Green peppers. Olives.
there's green and black olives.
No green. No.
Just black olives.
Just kidding.
But there's
banana.
banana peppers, jalapeno peppers,
I think there's white and red onion.
red onions. Is there white onions?
I don't think there's white onion.
I think it's just red onions.
There's red onions for sure, but then I don't know if there's white onions in like a little.
No, it's just a purple.
Jalapenos, just kidding. I'm bad.
Maybe it's just red onion.
So I don't get veggies with
I
mine.
have a list here.
You have a list? What else? Am I missing anything?
Lettuce, olives, spinach,
Spinach. I got spinach.
banana pepper, jalapeno, sweet onion,
Sweet onion.
and meats, there's more to that.
That's all the veggies? We have tomatoes. I'm pretty sure you can get tomatoes there.
I don't think your research is.
I just searched.
So for each of these,
I just searched up.
does it make sense that each of these would be 2? Because you could either choose to have them or not.
I'd like you to choose extra too.
Oh. Anything else for choices after that? Sauces. How many sauces are there? There's like 9 sauces, I think they 3x3 little, or is it 12 sauces?
Maybe 12.
12? Because they have like a tray and it's like perfectly rectangular.
Three.
Is it 3x3? So 9 of them?
But it's like more.
1, 2, 3, 4, 5, 6, 7, 8, 9. Sauce 1, sauce 2, sauce 3, sauce 4, sauce 5, sauce 6, sauce 7, sauce 8. and sauce 9. Each of those would be, you could either have it or not.
No, this is great. This is on somebody's website. Did you get avocado?
Avocado. I think
No, it's new avocado.
Carrots?
Ooh, avocado is new. There we go. We got another 2 up there.
Alright.
Okay.
I got this.
And then there's salt and pepper. Is it okay if I put them separate? Because you can choose.
Yeah.
So there's salt, pepper.
You want this?
Is there Parmesan? Is that with the cheeses?
No, it's like heavy.
Parmesan is at the end.
There's 11
Wow.
sauces. 11 sauces.
There's 11 more. There's
Yeah.
2 more sauces. So we have to add sauce 10 and sauce 11.
Yeah.
So now what do we have? Is that all our decisions? This is like, if you were telling someone, welcome to this restaurant, in order to make your meal, you're going to have to make this many decisions, you'd be like, I'm not going there. Okay, but now Subway decides to print out the complete menu. How many items are going to be on that menu? Well, after all of these decisions, what do we got? We got 9 times 12 times 6 times 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18. 2 to the 27. If we type this into our calculator, 9 times 12 times 6 times 2 to the exponent of 27, we get, and it's in scientific notation, just to give you perspective, this times 10 to the 10 would mean that after the decimal place there would be 10 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is an approximation because of course the last zeros we didn't put all the digits down. Could use a computer. But you would need to make a menu with 86 billion 970 million different options. And this would simplify Subway because then instead of having to make all these decisions, you could just go in and say, I think I would like sub number 1,385,286 today. And they'd be like, oh, perfect, I just made one. And then they would go through and just be able to do all of the stuff right away. And the menu would be this big for the takeout. So I think they're probably better not making a menu and keeping to the decisions as they are already. Okay? But extra credit. I'd like you to go to Subway. Order a veggie sub. Try to keep straight. You have, for the extra credit, you have to keep a straight face through this whole thing. When they ask if you want cheese, you have to say no. When they go through all the veggies, you have to say no to all of them. And yes to all the sauces. The sauce of Subway.
Do I get an extra mark for that? 'Cause I'll do it.
You have to keep a straight face
I will do it.
on video.
I'll do it right after school.
It's a waste of money, man. If they went first for the credit,
For the credit, yeah.
oh yeah. The sauce sub. And then you have to eat it in the restaurant. And every bite, with a straight face. Like, it has to be truly like, this is your favorite sub, and you've been waiting all day to eat this. What do you think the workers? What would they do? Oh, we're still recording. Okay, questions for practice. This is a unit also that we do lots of different, each question is like a little bit different. So we're going to take lots of time in this unit to work on this, or you can take the last half an hour to study for your test tomorrow. Questions 3 to 12 and 16.